Hey everyone, this is Sina with another episode of Into the Bytecode. My guest today is Alexander Long, the founder and CEO of Pluralis Research. So this was a conversation about the state of frontier model development and what it takes to get a new base model off the ground, what that market structure looks like, and why Alex believes it's important to have open, decentralized approaches for doing this. So we talk about how they're doing this with protocol learning, how something like this would actually work in practice. And we also talk about some more philosophical questions, like what the next few years might look like as more and more knowledge work can be done with AI. And I hope you enjoy.
I think a lot of people have thought about this idea of doing collaborative training. It's not a new concept.
Yeah.
I think people have been thinking about this for a very long time, but there's this non-obvious problem, which is the low bandwidth interconnects problem. So usually someone's journey is this. They think, okay, collaborative training would be cool. Why isn't this a thing? You go and read some papers and you realize, oh, there's this massive bandwidth constraint and this can't work and it's not worth trying. And, I had that information for whatever reason. In the sort of December of last year, it started to feel to me that there was no fundamental reason why this couldn't work, that it was being repeated sort of almost as a meme. And also you get to the point where you start to realize like, man, there are very few genuine experts in this area and there's only so much expert attention going around. And as far as the research surface goes, it's just blue sky everywhere. And you start to realize that actually, there's a chance here. Sustained effort on these problems can make progress. I became convinced because I saw some other people's papers that were published at ICML that were like taking the first steps at trying to tackle this problem. My feeling was if there was nothing here, there's no way those papers were ever published. So I sort of felt that there was enough data points that it was worth trying, and that led me to go and try and start Pluralis.
So you were saying that this problem of collaborative training is something people have cared about or been interested in for a long time. Why do you think it's interesting?
I think you have so many benefits of collaborative training that I could almost go down the list. But, one really key one is there is effectively no innovation at the base model layer today because the cost of training these models is so high that if you want to go in and experiment with new architectures, you need to go join OpenAI or Anthropic, or you need to join a hedge fund that has a ton of money like DeepSeek and decides they're going to try and work on this. In academia, there's really no innovation happening at the large model layer, and hobbyists completely forget about it. So one of the many unlocks of collaborative training is you actually have this possibility of permissionless innovation here. And the idea is that these models are going to affect everything and we should be trying to make them better as quickly as possible because the sort of upside here is just so large.
Yeah. So in the academic setting, it's because you don't have, I guess so there's the data sets that people have. Obviously, like having a clean training data set, if you're doing, say, more reinforcement learning as people are doing recently, like getting that data is difficult. And some of these big companies have an edge in curating and procuring that data set. And then you just need a lot of compute, which you may have interesting ideas of how to try new techniques and architectures in an academic setting, but you just can't put those ideas to the test in a real setting.
That's right. I mean, a good example I always like to talk about is Euthla AI that did that Blue model, I guess almost more than 5 years ago now. Before GPT, they trained this big BERT-like model. These are people that are hanging out on Discord, they know how to train models, they're extremely talented individuals, don't have huge amounts of money or access to huge amounts of money. So for Bloom, they raised money from European science grant bodies and they got that money, they did a big run. The model was the best model for a little while, I think like a month or two. And then I think some of the GPTs started to come out and what do people in that situation do? Go raise more money again? It's completely antithetical to how open innovation and open source should work. And it comes from this lack of complete inability to monetize the model layer while having some level of open innovation happening. And that's what Pluralis is trying to solve.
Mm. Yeah, so it's an interwoven kind of multi-layered problem, which is the only way to monetize a model is to what? Is to build basically build the infrastructure that can, I mean, one, you need to get it to the scale where it's creating value for end users, but then you need to create the infrastructure to serve it at scale, whether it's in the form of an API that folks call for inference or a product. And you need to have that potential ROI at the end of the tunnel to get the upfront funding to go and get the compute to do the training that is required. So it's kind of this, it's this chicken and egg problem, and the scale of training has advanced so far today that to even be a player that's relevant, you need to raise a huge amount of money to get started. So it's the activation energy is very high for a group of researchers who have good ideas in academia to get something new off the ground.
Yeah, I would say it's not only high. I would say the state of things today is it's insurmountably high. I don't think it's feasible for academics to accumulate enough capital to do a large-scale run in a non-commercial setting. I mean, if I was going to paint the picture of sort of the scale of releases today and why I think it's such a problem, I think you can put things in two buckets. You have centralized model development, where the monetization is very clear. You have a huge amount of money, like you said. You train the model yourself. You take all the risk of the run. If the run doesn't work out, you've wasted all that money, which might have happened in some of these labs, right? There's indication that that's happened a few times. And but once you have a useful model, you stand it up behind an API. Very easy to recoup the cost. Very straightforward. Very clear. Aside from the ability to monetize, almost everything about that process is bad. You have no ability to guarantee access for something which is going to be this critical foundational infrastructure, which makes everyone, we're getting to the point rapidly, if you don't have access to a strong base LLM, you're significantly disadvantaged as an individual. Your ability to
100%.
So you have no guarantee of access. You have no openness to the training process. You don't know what was actually put into how that model is going to behave. If you're trying to use it in a very critical application, you have this sleeper agent risk, which Anthropic talk about, where you can purposely modify the training process to make these models do different things in very niche situations, which you can't detect. You have no way of knowing. And you just have this general problem of innovation slows because all of the people need to go into these institutions to do any kind of R&D on this layer. It slows everything down. You can even see with DeepSeek, just having one additional entity suddenly sped everything up because there was this public release of some of these base techniques. So everything about centralized is negative for society as a whole, except for you mitigate some minor risks. If you're one of these people that think these models can be very dangerous, it's probably better if they're not open. It's very easy to turn them off in a centralized case, et cetera, et cetera, et cetera. That's bucket one. Bucket two is everything that falls under the category of open source today, which all of those aspects are better. Okay, you can have open weights, you can have the training process known, you can have, you don't really have an ability to actually permissionlessly participate. Someone still has to do the big run and you can't just join arbitrarily. But you have no sustainable economic foundation. All of open source today relies on someone training a large model and giving the weights away in some form or another. And, we're in this fortunate situation where some of these large corporates are doing that. And my view is they're doing it purely for strategic reasons. I don't think these businesses are charities. I don't think that dynamic is sustainable. And I think as soon as they have actually competitive frontier models, it's likely they will not open source those. And that's why there's this need for there's a third paradigm here, which is what I call protocol learning. You could call it, sort of openness of setup, closed weights, but it's this ability to actually monetize and recoup your training cost while having the development process be open, while having permissionless innovation, while being able to build on the model, and while being informed sort of how it was actually created.
Yeah, it makes a lot of sense. I guess maybe to linger on the setup a little bit more before we get into protocol learning. What does the economics of training a foundation model look like? So supposedly the open source and the closed source ones have a similar cost structure. And then the closed source ones have a revenue model that lets them recoup that. Like, what do these numbers look like?
In terms of like how much does it cost to train a frontier?
How much does it cost? I also reading your most recent paper. It's pretty astonishing to think about the level of compute and power that needs to go into training these things. Like, the numbers are actually kind of insane. It's like as much as a city needs to sustain itself goes into training a foundation model. So like, to the extent that you can give an intuition for what goes into training these things and what the economics look like, I feel like that's interesting.
Yeah. I think there's for a single training run, it's not as insane as maybe people think. But if you think about it holistically in terms of, okay, I need to do all these practice runs because they don't work right the first time. I need to be experimenting with different things. I also need, now a lot of the compute providers are very high inference workloads. So that's a huge amount of the cost too. Yeah, I mean, the numbers are mind-boggling when you look at some of this. So one thing I remember reading in the Llama technical report was things were changing on efficiency because during the different time of the day, accelerators were heating up or not heating up, and it was causing like megawatts of swing on the power draw. And you hear stuff like that, and suddenly you realize, oh my, it's just gargantuan.
Or they just keep the GPUs doing like random nonsensical calculations to keep the power steady, right? That's another thing I've read.
Yeah, because these big fluctuations in power draw affect the grid. That's kind of the thing, right? So yeah, scale of centralized model development is enormous, probably underestimated today. Cost of individual training runs, I think the estimates on that vary very wildly. You could probably train a GPT model today, a GPT-3, which originally people were saying that would cost tens of millions of dollars. I think it's got efficient enough now, you could probably train that in the hundreds of thousands. But if you want to go and train a DeepSeek V3, you're in the tens of millions. These are the tens of millions, potentially hundreds of millions for single runs.
What's actually becoming more efficient there over time?
Everything in the architecture and the training setup and the sort of training recipes. Like, we're kind of seeing what always happens with new technology, which is the first version is this hobbled together. No one really understands why it even works. There's many suboptimal decisions in the design, but it works. And then you have this immediately exponential decaying cost curve where like semi-obvious things just drop the cost to train by 10x. And then as more and more attention is stacked onto it, the benefits start to sort of be less and less and less. But right now we're still on the very fast decaying part of that cost curve.
Okay, so maybe getting into protocol learning. So how would you describe that? What is protocol learning? How do you conceive of it?
Yeah, protocol learning is a way to train the models in the swarm in such a way that no one actor can ever obtain a full weight set of the model. This is a very novel, very strange setting, but Pluralis's view is that this is necessary to lock value to the protocol, and that if you can't lock value to the protocol, if you have weight sets floating around that can be stood up cheaper and other endpoints that can be stood up cheaper, you don't get this path to true collaborative training because you're unable to enforce incentives and have trainers recoup their cost.
Yeah, so you need to train the model in a decentralized setting, which has a bunch of requirements like being Byzantine, fault tolerant in various kinds. Certain nodes might be trying to inject bad data or bad, updates into the process. You need to account for nodes being unreliable, like joining the network, leaving the network. You need to account for these lower bandwidth, lower fidelity interconnects because these are servers, computers hooked up to the internet. But then outside of all of that, as the model is being trained and once it's fully trained, you want the weights to be locked into the model in a way that no outsider can freely read them. And this is what gives that kind of decentralized cluster the ability to then serve that model and monetize it.
Gives you the ability to monetize. You prevent value leakage from the protocol. So, and it's even more extreme than you mentioned. It's not only no one outside the protocol can obtain the full weight set, no one within the protocol, no one training the model can actually even obtain the full weight set. This means the model only lives in the protocol. There is no other instantiation. It's not even fully materialized at any one point. It's only in the protocol.
So how does that work? That's pretty crazy.
Yeah, it is kind of crazy. Well, you can exploit actually sort of structural features of distributed training and how neural networks work to achieve that property. It's sort of very non-obvious, but as soon as you define the setting and what you want to achieve, actually the ways to do it become kind of clear. The way neural networks work is they're these big, like sequential operations. So I would have layer 1, layer 2, layer 3. I feed these things through, I calculate a loss, and I do a backward pass. It kind of becomes very intuitive. If I have 10 participants and 10 layers, if I can enforce identity and I can place people where I want to place them, I can give participant layer 1 and layer 1 only, and layer 2's address. And I can give layer 2, participant 2, layer 2 weights, et cetera, et cetera, et cetera. And I can structure this thing in such a way that no one person ever sees a full weight set during training. A lot of the challenge there becomes like, okay, how do you enforce if people are trying to go through and, operate every node and sybil across the network and extract things out? But maybe that gives like an intuitive explanation of how you can achieve that.
Yeah, because this is what's happening already with training, right? Like these no single GPU or server is holding all the weights.
It depends what type of training is being done. If you do data parallel, everyone gets a full weight set. But if you're doing large scale 4D parallelism, which is the kind of thing you would do in the standard centralized case, yeah, you're never keeping a full weight set on the accelerator doing the computation. You almost certainly have full weight sets floating around as model checkpoints and just stored in storage, but you're not keeping model weights complete in device. That's kind of the whole point.
So what are you designing for here? Are you imagining that is this like different academic labs with their own, single H100s that they're joining and participating in this network? Or are you imagining it's like everyday people with like a computer plugged into their home, into the wall?
I think there's different sort of groups where it becomes very pronounced at different scales. So I think initially it's all these hobbyist people that basically have no path to participating in this layer today at all. And for those people, it's not even about making money. It's sort of these open source ideologues that just want open models. And you can even see this in the local Llama subreddit. Like someone mentions something like this being possible and people are just like, I'm going out to buy a 4090 now, right? Like people just want these kinds of collaborative runs to exist. At the other end of the scale, there's sort of sovereign level collaboration. So, you scale this all the way up. Countries like my native Australia have no path to creating large foundation models today. They don't have the infrastructure set up. They don't even really have the expertise. Effectively totally locked out from this layer. And you can see how for a country like Australia, where 60% of the economy is knowledge work, and you're rapidly automating and augmenting large portions of that, it's just a massive capital flow out of the country to the country which is actually vending the models. So countries like Australia very soon, I think, are going to wake up and realize we need to have our own versions of these. Wow, we don't even have the sort of infrastructure set up. We also, potentially even the cost is too high for us to bear, like at the sovereign level if these things get really crazy. And so you might have actual like sovereign level coalitions, trustless coalitions, creating these models in protocols, guaranteeing some level of access to them, knowing that the training process is like known and clear and open, and then recouping some of the actual training cost rather than just giving it all to the states or American companies.
So that's where you see it going, like given how big of a deal this is and that our entire civilization is going to run on these foundation models going forward. At some point, if you're a country that isn't able to train their own foundation model, which is most countries probably outside of US, China, maybe a handful of others, then your incentives are to try to get a neutral, third option and neutral, open source option that no one can kind of disintermediate you from, and that can also be a source of potential revenue, right? The more you contribute to it, the more you can get back from it as well.
Yeah, I think this is much more on the speculative end. There's a lot of intermediate steps before something like that happens. But it's this key property that, exactly as you mentioned, you recoup proportional your contribution. And so, if the risk profile for big run or the cost for big run is just too big for any individual or group, you have this property where you can have fractional ownership and then also fractional benefit if the model is useful. And you just don't have that in any other setting today.
Yeah. So in the beginning, when it's hobbyists and, open source developers, how would something like this work? Are you thinking that people would sign up and there would be some sort of a, KYC process where someone's an end individual? Or is it a more kind of like technical solution where the nodes are, maybe they run inside trusted execution environments and they just, they don't know the weights and so they can't share them with other people?
We definitely don't need to use TEEs. So you can exploit this property I mentioned before, that if you have one shard of a huge model, doesn't really help you get full model utility. If you have 1/1000th of the model weights to do your little local computation, if your goal is to then reconstruct a full version of the model,
you just can't.
That problem reduces to the original learning problem of learning the entire model. Plus, you now have 1/1000th of the known parameters. It doesn't help very much. So, don't need TEEs, at least for our version. You definitely do need to do some kind of work verification, because as soon as you have a large scale run like this, not only will there be people trying to extract rewards and incentives from it, there will be people that just try and derail training runs. There's no question in my head that there's going to be people that will do that. And so you need to have robustness to not only incorrect gradients, but malicious gradients. And there's sort of a range of solutions there, from like the really heavyweight ZK stuff to some more like maybe a bit more lightweight game theoretic approaches. But you have to have that. You have to layer in the incentives as well. To actually,
that's a complicated problem, right? Because even in the centralized case, making these gradient updates converge and not have these like big spikes as they update is a lot of where the craft of training these models is, right? Is my understanding. Because the kind of like naive setup of you just do back propagation and gradient descent, that's like easy. It's like, how do you update these weights? And so if someone's intentionally trying to engineer them to like make the training run not converge or to do the wrong thing, that's a pretty difficult case, or that's a case that you need to design for.
Yeah, but very fortunately, there's actually very deep literature here. It's sort of Byzantine robust optimizers that came out of the centralized case, because when you train on these big scales, actually things just break. If you're using 20,000 devices and you're running them continuously for 2 months, the likelihood one of the device just shuts down is very high. It happens all the time. And so even in centralized training, people have been studying Byzantine robust optimization. But it's in the random case. It's like non-malicious faults. And what has to happen in the decentralized scenario is you have to extend that theory to the fully malicious case to, okay, can someone design a gradient here that would derail the entire run? And there is some early work on this. It's very encouraging. Like you actually can have convergence guarantees still in this setting. So of all the problems that need to be solved to sort of get decentralized training to work, Byzantine robust optimization falls very much in the feasible category there.
Okay, so you do some kind of work verification for these nodes, and it's very difficult for them to basically be able to do inference runs while like knowing only the weights of the node that they're in basically precludes them from having any real, being able to like run this model in any shape or form. So you can be relatively relaxed in how you try to lock up that data, as long as you make some, collusion, resistance assumptions of like what portion of the network is potentially going to talk to each other and things like that.
Yeah, that's exactly right.
So can you talk through like how would this actually work beginning to end? So I want to join a network like this. And obviously not getting into the things that you're still researching or that you haven't published, but maybe to do a sketch of the architecture that can give a mental model of what's going on, you know? So I'm running a node, I'm communicating with nodes that are before and after me in these layers. I may be asked to, I'm basically, what is this computer actually doing? And how does it all kind of unify together to have this model that can then be used for inference after the training is done?
I mean, if we just think about inference, if there's a trained model that's stood up and it's distributed across participants and you would like to sort of assist in hosting inference from an operator's point of view like that, it's like you announce to the swarm, I have this device, I have this capacity. You're assigned a weight shard. You're assigned an address, which is going to be the subsequent layer that you need to pass that shard to. You probably need to establish like a secure communication link with the previous node because you don't want the actual communication to be intercepted. And then you're going to get activations. You need to compute the forward pass with those activations. You need to pass the result to the next node. So from an operator's point of view, that's
all you need to do.
That's what you need to do.
And how big are these models going to be when they first come out?
I mean, the first versions are going to be, sort of in the tens of billions, hundreds of billions. These sort of proof of concept runs that showed, what I'm saying is not just crazy, but it can actually work. But the really appealing thing is when this flywheel starts spinning and you have compute starting to assemble these protocols, you can make these models enormous. And the amount of decentralized compute you can assemble, we talked about how big centralized compute is and how it's sort of mind-boggling. Decentralized compute goes on to another order of magnitude. It's about 2 orders of magnitude bigger. And so you actually have this path to really enormous models being assembled in this protocol. And you also have the benefit, by the way, of centralized actors can contribute to protocol models, but not the other way around. So if there was a scenario where someone like Google was like, wow, there's a really large run going on in the Pluralis swarm and it looks like it's going to be really good, we should make sure we have like some level of ownership and influence of that model. They're able to contribute data center compute to that. So you kind of subsume centralized model development in a way.
So given that in the centralized case, there are basically ideas that you'd have as a researcher and you'd test them out and you'd scale them out and there's failed runs, and how does that process of developing a thesis for how to design a new model go in this case?
I think it's very similar. So you wouldn't be trying to monetize runs that are research runs. Those things I think have to happen either in what you would almost call shadow pools, where everyone knows this is not a commercializable model, but we would like whatever intangible information we learn to sort of stay within this group, or they just happen outside the protocol anyway, because you would assume they're not on the scale of the really large run. So I think the actual innovation and development side of things happens very, very similar to the centralized case. But you then have the path of, I can now convert that into an actual monetizable run when I want to.
Okay, so I guess putting myself into the shoes of an academic researcher, and I have this new idea. There will be a network out there that I can pitch this idea to, and if it seems like a compelling direction, the network will opt to train it.
Yeah, the compute should show up. Like the example I would give is if UFLA said, hey, we have this crazy architecture we've been trying at small scales, it seems to work really good. We want to kick off a 50 bill parameter run of this thing. We think the scenario here is this has broad use, and this scenario. I personally would put some compute in something like that because I want to know what that would be. And you got to contrast that with what they were doing before, which is go raise money from European grant bodies.
So this is what the kind of like politics of convincing the compute that your architecture is promising looks like. You have to go out there and campaign for it. And these are basically self-interested economic actors that if they think what you're proposing will work, and will generate revenue on the other side of it, then they'll do that.
That's exactly right, yeah. And it gives this benefit of, if you're a compute operator, you can have a portfolio of model risk because you're not required to put in all the compute for a run. So you can have, okay, 10% of my budget is this very speculative thing that this group no one even really knows is proposing, but it sounds interesting. Or, okay, we now have this very known recipe that's basically a GPT-4 scaled up version with more data, very well-known people. It seems likely it'll be useful in many scenarios. I can allocate a certain percentage of my budget to that run, and you can have a portfolio of these models, but you don't have that today.
And is this network kind of training these in serial, or how do these get queued up? How much time, I guess, like how much compute time do they take? Like in practice, what is this going to feel like? Is it like a model goes in and is being trained for a week, and then the next one comes off the queue?
Totally. So multiple model runs in parallel, doesn't have to be one after the other. You're just constrained by how much compute you can attract into the protocol. And my view is actually compute flows wherever there's value. So if there's valuable models being trained, I think the compute shows up. As far as duration goes, totally dependent on the model proposer. So if someone's doing a really large scale run, it might go on for months. Someone might even propose some kind of continuous learning run where it's just the training is never stopping. There's sort of just incremental inference happening. Or it could be very short scale. Could be a couple of days, a couple of weeks as well. Totally up to the model designer.
Right. So the different nodes in the network can keep states and just know where they are in various training runs in parallel, and dynamically tune up or down how much compute they're allocating to each model based on what they think is valuable. So the market mechanism isn't like only at the time when a new architecture model idea is being pitched. It's kind of happening continuously through time as people get a sense for, is this model going to converge or not? Like how is the competitive landscape shifting? All those sorts of things.
That's exactly right. And some of those, I think, are very specific implementation details that I think can be TBD, but the core sort of property is that you can move in and out of runs as an operator. That's 100%.
Interesting. Okay, so then a run is complete. What happens then? So now the weights are locked up in these nodes. How do they do inference themselves, or is there some sort of like extraction and projection into a different architecture network that does inference?
No, so inference remains in the swarm. Sort of same training swarm that was used for training is also going to host the model. And you have now the benefits of that, the fact that it's locked to the protocol, downstream use, which from a user's point of view, it's the same as calling an API. You're calling an endpoint that's going to the model, that's giving you a result. You're paying for that to some extent. What's unique to protocol learning is that payment is then flowing back to the trainers and the hosting providers right within the swarm, proportional to their contribution. And they're recouping that massive cost, which was put up to train the model in the first place.
Into the Bytecode is sponsored by Splits. Are you tired of sacrificing security for usability? Splits believes it's still way too hard for teams to self-custody their on-chain assets. They're building a new kind of internet-native bank on top of Ethereum. Splits makes it easy for teams to manage the whole lifecycle of their finances, from structuring revenue sharing agreements, using payment flows like splits and waterfalls, to managing those earnings once you receive them, using passkeys and smart accounts. Splits is being used by teams like Protocol Guild, Zora, Songcamp, and others. I'm a big believer in them and recommend checking them out. You can learn more at splits.org. So I've heard that part of what's really complicated about serving the latest generation of base models that then have inference time scaling is that the training and the inference are kind of require different things of nodes, right? Like at inference time, you need a lot of memory available, and I may be completely off here, but because you're generating this internal reasoning trace, and there's a lot that the model needs to kind of like keep track of, this makes it difficult. And this is why, with DeepSeek R1, there's not that many providers that are doing a good job serving it, right? Like on Open Router, a lot of them keep going down, even though this thing came out a couple weeks ago.
So the reasoning models are memory intensive on inference. That's definitely the case. It's not really the case that you would need some kind of specialized device that you wouldn't use in training to do inference. So my bet, I don't know the details, but I would bet a lot of these hosting providers are using the H100s to do it. Like the biggest cards they can get, I'm quite sure would help you do better inference. So not a scenario where you kind of need to move to a different device, but is true that they're very memory hungry. You need a lot of memory to do inference for the reasoning models.
Right. So then these servers are both doing training and inference. And so if you're planning to participate in these networks, you probably need to buy a pretty beefy, like dedicated device to have there.
Oh, this is a good question. This leads me into like, there's different things that are falling under the same umbrella of decentralized training, and I think are very different concepts. So if you wanted to do data parallel decentralized training, where, data parallel is the simplest parallelization method. Every node has a full copy of the model, and you just sync gradients periodically. Then you have this exact problem where every node has to be very, very large because it has to keep a full copy of the model. So, every person has to have eight H100s there going, co-located. This is not what I view as true decentralized training, because the bar on participation is still very high. And as you get even bigger models, it becomes beyond just a DGX rack. It becomes like you basically need data centers to train a local node. So what you have to have is some kind of model parallel training. Model parallel is when the model itself is split over these nodes. This is very different. The communication intensity problem becomes even more pronounced in this setting. Most people think this can't work at all. Like, it's extremely fringe. I should emphasize that. Like, most people do not agree that that's even possible.
That model parallel is possible?
The model parallel decentralized training is possible. That's right.
So this is where a node, what does model parallel mean exactly?
If you can think about it as there's all these parallelism strategies, but you basically at the top level have data parallel, where every node has a full copy of the model. And then you have all the model parallel techniques, which are in some way the model is split over devices. This is the thing that most people would say, forget about it, can't work.
And why do they think it doesn't work? It's not going to work.
It's because of the communication efficiency and the low bandwidth problem. So in a centralized case, all the devices are co-located. You have InfiniBand connecting the racks. Your sort of node-to-node bandwidth is in the hundreds of gigabytes. In the decentralized case, your node-to-node bandwidth is in the, a good speed would be hundreds of megabytes. So you're on the scale of 1,000x reduction in bandwidth. In the data parallel case, it's tolerable because you can do many of these local steps and you can do a very infrequent outer update. You only have to wait, potentially one every 1,000 local steps. So it's kind of okay. But in the model parallel case, every forward pass is requiring these very low bandwidth connections multiple times in every forward pass, and then also multiple times in every backward pass. So the communication overhead just becomes really, really pronounced.
So how do you do it?
I don't know. That's probably not what I want to go into now.
Yeah.
I'll just say Pluralis is focused on that problem. We think we can. We think with sustained attention on it, there's ways to make progress. I think no one is really, really focused on trying to solve that yet. Maybe the way to characterize it is, as far as research goes, it's just blue sky everywhere right now. There's more things to try than there are researchers to really focus. I don't think this is something where we're in this established field and it's like a breakthrough to get something like this to work. It's more, no one knows why anything works. Has anyone even really focused for a prolonged period of time on this problem? I think it's maybe not. And we might have some stuff to say on that sort of shortly. But as of now, I think we'll see.
So this problem in the model parallel case, where for each forward pass and backward pass, the node needs to do network I/O alongside the compute that it runs. This problem gets exacerbated at inference time if you're doing inference time scaling, right? Because now each run that you're somehow sampling from and averaging from and trying to like pick the best answer cohesively out of requires multiple of these forward passes.
Yeah, that's right. That's right. In a reasoning sort of inference time scaling paradigm, you forget about applying standard distributed inference. If you can't solve that communication bottleneck problem, exactly right. There's no way.
So does, as the focus has shifted to these reasoning models, does that change the approach that decentralized networks need to take to be, I guess, and also kind of looking into the future as someone who's been working on this for a long time, right? There's kind of like upfront pre-training techniques, and then there's various post-training techniques, there's inference time techniques. If we're designing these networks to be valuable, serve the models that train and serve the models that the world is using down the line in 5 years, 10 years, 20 years, timelines. I guess the more, specific version of the question is how do you, what proportion of the intelligence of a model comes from these different techniques, and how important are they to kind of design for in the decentralized setting? And then the more meta level of that question is, how do you kind of design the network to be able to adapt and be flexible in a setting where we probably can't predict where the collective ingenuity of humanity will take us?
Yeah, those are great questions. I think that the majority of value remains in strong base models. So if you look at the relative training cost, there's no doubt in my head we're entering this period now of inference time scaling reasoning models. These are here to stay. They're not going away. You can train these things, and all you need is a verifiable reward, and they will get better at that task. So I expect we're going to see really massive progress there, and that will accumulate more and more of the compute budget as we go. That's also very clear. But we're still in the scenario where the quality of those reasoning models is limited by the quality of the base model. You cannot reason your way to a really T1 model unless you have the base there. And so that's where a lot of my concern remains. If we don't have if Llama 4 is not released, or DeepSeek V4 decides to stay proprietary, we're stuck with V3, we're stuck with Llama 3. The sort of closed proprietary reasoning models will continue to get better and better and better, and the open source, I think, will remain fundamentally limited. And we have this kind of pressing need to have some kind of collaborative training to create these strong base models. So I view them as a key. I also think it's very clear how you can train reasoning models in a decentralized way as well. So you kind of have a very fortunate scenario, actually. If you solve the base model problem, it's actually easier to train it in this PPO way and in decentralized settings. You can do that.
How would that work if you were to just, again, sketch it out at a very high level?
Yeah, I can explain. Maybe it's probably first useful to explain how you train a normal one, and then I can explain the difference in the reasoning setup. So normal LLM training, probably a lot of people have heard, it's just, you would call it autoregressive self-supervised learning, predicting the next token, and then you have a cross-entropy loss on your, you basically have a distribution of what you thought the tokens would be. You have the correct answer, you define a loss, and then you make the model more likely to predict the correct token, less likely to predict the incorrect tokens. The point is that this happens at the per token level for big text corpuses. And you're basically saying to the model, I want you to produce text like this. This is the supervision signal. Clone this text. It's the same thing that happens when you do supervised fine-tuning, is you're just giving it instruction style
training data. Yeah.
Exactly. But you're doing it at the token level. And there's a backward pass for each token. So it's one forward, one backward. What happens when you change to this GRPO style objective, you're only giving it the signal when it gets the answer right or wrong. So it's generating a huge amount of text. And then you're saying, okay, you generated 100 answers. 2 of those you got correct. You got to the right thing. And you have this verifiable way of knowing. So this is why these things are trained with maths and code, because these solutions are verifiable, if they're right or wrong. And then all you do is you say, okay, make that entire trace more likely or less likely. So all the ones that got it right, make the model more likely to output that. All the ones that got it wrong, make the model less likely to produce those. And so the amount of generation you have to do versus your one training step, that ratio changes significantly. And so you can actually have local nodes that don't even need to do backward passes. As long as they have a copy of the model, they can generate the reasoning trace, pass it back to some centralized node. They can accumulate hundreds of thousands of these answers, and then they can change the base model parameters that way. So I think it's very likely we're going to see a lot of this kind of stuff, these open collaborative sort of post-training runs for that reason this year.
That makes sense. That's exciting.
Yeah.
And I also was wondering about the meta level question of how do you stay adaptable?
Yeah, I think if there's something really comes out of the woodwork, like spiking neural networks start working, and it's a whole different architecture, I think it's very hard to design a protocol that would support something like that today. But I think, if we stick with this paradigm of basically gradient descent, which is powering all of these things, and you need optimizer steps and backpropagation, I think you can be quite flexible to the actual style of post-training, the objective and the loss, and you can be very generic in how you design those aspects. And it seems very likely to me that's the sort of paradigm we're going to stick in for the next little bit. I think the architectures will change, but that general paradigm of gradient descent, I think we're staying there for a while.
Yeah. And even though the architectures will change, that the paradigm stays the same. So you still need to do the forward, backward pass.
Exactly. If something changed where it sort of broke the local nature of computation, I think that would also be difficult. If it wasn't this sort of, okay, node 1 can compute some subset without seeing the entire model, it doesn't need to see. If that changed, I think then we're in a very different world. That would also seem very unlikely to me at this point.
Right. But at the social layer too, I mean, the fact that this will be basically an open source, ecosystem means that even though it will be harder to make architectural upgrades than relative to what a centralized player would have to do. But on the other hand, you have all of these researchers and developers' eyes on this thing who want to contribute to it. So the problems are kind of deeper and more complex, but you also have more firepower behind them, potentially.
Yeah, and I don't think it would be, I think it would be quite straightforward to propose new architectures in a scenario like this. If the architecture is able to be divided into modules that are somewhat sequential, you can assign arbitrary modules to participants. That should be fine, as long as the computation is coming back in a normal way.
I mean, that's effectively what a model designer does, right? They somehow formalize their architecture in a way that these nodes can download and run.
Exactly.
Yeah. So you were saying that you expect reasoning models to stay around, but that the fundamental values in the base models, because if you don't have a good base model, it doesn't matter how much, rewards-based reinforcement learning you do on top of it. It just doesn't have the number of parameters to like absorb that information.
Yeah, that's right. I mean, to be clear, I think there's scenarios where you could get a reasoning model really good on a narrow task. If you've got a really good verifiable reward and you train it for a long time, maybe. Still, a better base model is going to get to a better final thing, but it's like maybe you get sort of similar in performance. But for sort of broad general reasoning models, yeah, you're really constrained by equality-based models still.
Yeah. So I guess playing this out a bit, let's assume that such a decentralized network is able to bring together a vast amount of compute and to train a base model that is larger and better than what the closed companies can provide. Is it the case then that you'll have this very strong base model here, but it's more do you think this kind of open setting would be limited in how much inference time it can do versus what decentralized providers can do? And then what would the dynamics actually be between these, right? It's like how do you see this playing out? Because if I'm OpenAI, I basically see that this new architecture worked out and was successful. I also can potentially use distillation and make inference time calls against it and use that to train my model, which I'm generally curious about. Seems like a very interesting dynamic of this whole space, which is basically impossible to stop. So how do these forces play out together in practice, assuming that such a network actually does work in the ways that we're describing?
Yeah, here's what I think, okay? I think there is no actual open source, no true open source at the model layer today. So we talked about it at the start. I think these open weight models, it's not open source. And my view is historically, if you ever have genuine community engagement and like you have the base trunk of the tree that's just pushing everything forward, it doesn't matter when a centralized company branches off, they can get ahead for a little bit, but that main trunk of progress that has all the researcher attention, all the academic attention, all the effort that's going there because people know it's truly open, it always ends up moving faster in the end. And the lead becomes just, you can make this small advancement for a quick amount of time and then you just get overtaken by this torrent of progress and attention. And that's what I think will happen in this case is you're going to have all the innovation actually happening in protocols like this because there's no way to do it today. All these people are completely locked out. So if you actually facilitated it, a lot of people would participate, and you would expect the velocity of the innovation that's happening within those protocols to be much faster than what's happening in any centralized case. And I think it will happen. People like OpenAI will just take innovations out of the protocols, stand up centralized cases. They'll make them a little bit better for a little period of time, but eventually the openness will always win. The sort of any ability to have actual innovation, permissionless innovation, will always overtake those other dynamics.
So what will assuming that this is the case, which would be a really epic future to live in. So there's this open source trunk that just has way more resources, way more researcher attention. It's moving faster than any centralized party can keep up with. Assuming that's true, how does that reshape the landscape, the market structure? What are these companies doing? How does an average developer building an application incorporate inference into their application? Like how do things change?
Yeah, I think as far as people building on top of the models, I think it's very similar. So you're effectively making an API call in the same way that you would to a centralized provider, and you're paying for it because you need that payment to recoup the cost of training and make the whole thing sustainable. So as far as building on top, I think it's very similar. You just have potentially much, much better models, and you have a guarantee of access, which you don't have today. So if these things are built in open protocols, you can't get just arbitrarily shut down and have your access removed and not be able to touch them. You also have a far greater degree of transparency if the data mix and the training mix is known, rather than if it's trained centrally and only the endpoint is released. So you get all those benefits of sort of an open model combined with the actual economic sustainability at that layer. As far as an actual participant in the protocol, I think you're gonna see all these sort of like splinter groups. There'll be people that'll be training their own thing. They'll be claiming their version of the models is better. They'll be actively advertising, saying ours are more open or less biased or have this feature which is better, and trying to sort of win the the mind share at the model level. And at least initially, there'll probably be a very large period of fragmentation where it'll be like that, multiple competing models, things like this. However, you can see it in the long term coalescing into sort of 1 to 2 broad coalitions, and then probably eventually very few number of very large models.
Why do you expect that to be the case? Because I have very low switching costs as one of the compute providers, right?
Exactly. I think it's more there's very low switching costs in the model use. So because it's literally just an API call, if 2 groups are training GPT-4, it would be significantly more beneficial for them to combine and train GPT-5 if it's just a matter of compute budget. Because as far as model users go, exactly, it's very low switching cost. So you will just accumulate to the one that has better, larger, broad utility. And if you don't have cooperation like that, someone else will, and they'll surpass your small fragmented models, and you'll end up with very little use.
So it'll be kind of like the first past the post system in politics, where it's like you have to, if you're like too many independent parties that a user could go to, neither of you might clear the threshold of the other competitor. So the incentive is to kind of build these coalitions. And then as those kind of start to grow in size, then the incentive of every other player will be to join them because they can't beat them.
Yeah, I think in the limit you end up with the compute coalesces to a few runs. I think that's largely correct. Yeah, potentially one big run.
So as a researcher, so I come and propose my breakthrough new architecture. In this process of doing this, if it's successful, I start to build some kind of reputation in this community and people come to trust my voice. Do I get any kind of, compounding advantages or defensibility beyond that,
Yeah, I think you have I don't think you get them in the protocol, but you have all of the soft things that exist now. Like someone can develop a strong brand. And it's very, very hard to put a value on that brand, but it exists and it's real. And if someone that is good is proposing a run, you're much more likely to contribute to that. So I think you have all of these soft reputation things that I don't think you can tokenize, I don't think you can quantify, but they're still there and they still matter. I mean, there's the whole risk side to this, which is if you get these things working in big protocols, the one other advantage you have in the centralized case is you can turn the thing off. And I'm not one of these extreme doomer people where I think these things are about to gain sentience and we have like a Skynet scenario. But there's very serious people that do think that. People a lot smarter than me that do think that. And I think you have to treat these things with some level of seriousness. I think it's irresponsible to just dismiss them out of hand. Especially because I think already we're going to see economic impacts that are going to be very serious soon. And so I don't think you want to downplay these things. I think there's a real risk that if you have one of these self-sustaining protocols going, it becomes very difficult to turn the model off, especially if you are linking participation in the training run to model utility. Because if something really starts to approach a dangerous level, it will also appear the most useful. And all the incentive actually will be for people to participate and join. So it's even worse than just we can't turn it off. It's actually not like, as it approaches any level of threat, the dynamics are set up to accumulate compute, self-reinforcing. So I think out of all the benefits, I think that's a real serious risk. I think it has to be taken seriously. And probably that means some kind of emergency stops in these protocols by trusted parties. I think that's where that ends up.
Yeah, because the incentive of the majority will be to contribute to this model. And your economic alignment is you're economically aligned with that happening.
Exactly. If the core feature is permissionless participation, you can't stop people from joining a run, which is a core feature of Pluralis. And we have very capable models that are maybe starting to blur the line, and that it would actually be prudent to just pause and consider what's going on here. This is a very speculative scenario, to be clear, but this can happen. all of the incentives would be for compute to flood towards that model because it's so obviously useful. And even if the people in the run are like starting to get freaked out and leave, other people would just join. They'll take their place.
How likely do you think this is to happen? What's your own personal feel for these sorts of risks?
I put it in the very unlikely category, but the way I think about risk is its probability and magnitude. And the magnitude of that is really, really large. So even if it's very unlikely, I think you have to take it very seriously. If I was going to put a number on it, for me, it would be less than 1%. I think it's very unlikely.
Why do you think it's unlikely?
I don't know if I have a good answer to it other than it's just my gut.
Yeah.
My gut is just that so many things have to go right and so many innovations have to happen for us to get to something like that. The exponential has to not slow down. I think much more likely is, we have this scale of model risk. There's all these scenarios where these things are going to affect society. And what seems likely to me is we're about to have major labor displacement. So we would kind of have to get through this period of like massive societal turmoil where a huge amount of people it seems very likely now, a large amount of people are going to lose their jobs. A large amount of companies are going to go out of business. And we're going to have massive, basically like economic polarization, where it's just the companies that control these models are just going to accumulate so much value so quickly. While at the same time, the sort of relative effectiveness of every individual is just in free fall. If you're a normal knowledge worker type person, your sort of relative value is in decline. That to me seems like a very likely serious risk. And we'll have one of my favorite books is like Play a Piano by Vogenoy, right? It's like the machines just do everything. And the economic value of the average person is not high. That seems very likely. And it seems like it would cause huge, big problems. And I'm much more worried about that than I am about, okay, we have some kind of massive misalignment.
That comes later anyway, so we have to solve this first problem first.
Exactly. We get the labor displacement before we have anything like sentience or a runway model or anything like that.
As someone who's thinking about these things a lot, how do you think that the next 5-10 years will go? And do you have any ideas on this question of labor displacement?
Yeah, this is a major reason why I think Pluralis needs to exist, or a company like Pluralis, because your average person has no exposure. And as soon as you're creating these things in open protocols and you can join and you can buy sections of the model, you can contribute your compute, you could speculate on which model you think is most likely to be useful. You give a normal person who's, in my view, potentially in a very serious economic situation shortly, actually exposure to something which is just going to be critical infrastructure. And you give people this partial ownership of these things which are just going to be critical. I think the only other way you get something like that is you rely on governments to implement some kind of UBI. And I don't have faith in governments acting fast enough to sort of counterbalance what's coming. I think much more likely is it's too late and then it's an overreaction. And the overreaction almost causes more problems. I think this is, historically, you see this repeatedly. You have to have some kind of open development where normal people can participate in the monetization. I think it's really critical.
Yeah, it really feels like we're in the calm before the storm, if you can even call this the calm.
Yes.
But I feel like it's very close, this moment that we're talking about, and most people don't realize.
It feels to me like in the cartoon where like the coyotes run off the cliff and it's spinning its legs and it hasn't started to fall yet. And everyone is walking around acting like everything is normal and things are very not normal. And I think you're right. I think reality is about to hit very quick.
Are there, maybe as we kind of get to the end of our conversation, are there any other big questions zooming out of protocol learning, which has an answer to a lot of the big existential questions like you're talking about? Are there any other questions that you think are important that we should really be thinking about at this moment in time?
I think the labor issue is really the big one. What are these what are these smaller countries going to do that are primarily knowledge work that don't control these base models? I think the other aspect you have to that is there's this sort of clear national security / military impact of ownership of these models. And I don't think we've really seen that kick into high gear yet, where there's likely going to be quite severe geopolitical tension. We're sort of seeing the absolute beginnings of that now, I think, with DeepSeek in China. But there's almost certainly going to be a big drive out of the Middle East to create a sovereign model. The sort of awareness that this thing is, these models is just a clear national security issue that you have to control, you have to have your own, or not only are you disadvantaged economically, you're disadvantaged militarily as soon as these things are doing any kind of assistance in military planning, which they will shortly. I think this sort of AI arms race scenario that a lot of people talk about is very real and will probably start to happen quite soon.
Do you, in the kind of military geopolitical lens, do you think large language models specifically will play a role in that? Or are you kind of talking about the larger trunk of AI development?
Yeah, I think LLMs already are getting the point where they have clear, useful military applications.
Yeah.
But yeah, we're moving
if only for planning and like doing the intellectual work to like design things.
I have a friend that does sort of, his company was doing command and control AI for a long time. And it was all historically done with symbolic methods and, these old planning methods from the 80s. All these things now can be solved with big, strong LLMs if they have the context. So yeah, I think we'll see that shortly.
Crazy times ahead.
I think so, man. I think we're in a way, we're very lucky. We get to live in a very interesting portion of history, but there's
100%.
Also many scenarios here where it goes very bad.
Yeah. Maybe as a kind of more current moment, lighthearted question, which relates to all of this. So you're building a new company, a new institution, a new organization. And I feel like one of the moments of change we're in is that there's a new AI native way to build companies, right? Whether it's like in your research process as you're like designing the systems we're talking about or otherwise. I'm curious how you think about that. Like, how are you building this company differently than you would have if it was 5 years ago?
Yeah, I think you have sort of obvious things where individuals are just way more productive than they were 2 to 3 years ago. So all of us in Pluralis, our productivity is significantly increased by just using these tools. And we use them for research, or if we want to generate graphics, we use Midjourney, all these things that normally we would have to pay people to do. Just very easy, straightforward for us to do ourselves. So the individual gets magnified a lot. And I think about it as normally it really is a magnification. So if someone's good, they get amplified even more because they can kind of figure out the best ways to use these tools. And so it becomes about talent density, in my view. Can you get a small group of just really, really outstanding people? And then the sum of those parts is even more than it used to be. Now it's like the sum of those people times the AI amplification. And you get these very, very effective small groups, I think is what's going to happen. And a lot of people have talked about this. I think you're going to see small, very large companies. Midjourney, I think, is like 10 people or something like that.
No way.
Yeah, it's crazy.
10 people?
It's something on that order. Yeah. They might have hired more people now, but I think they got to $1 billion ARR with less than 10. So I think we're just going to see more and more of this. I think we're going to see there's another sort of movement going on, which is it's been happening for a long time, but just people are really no longer constrained by geographic borders. So I think you're going to start to see, even though there's currently a big drive back to America because of the new administration, I think you're going to start to see companies that are just headquartered in strange places with people that are not part of that group and were never networked into that group, but sort of use these tools to bootstrap themselves up into effective positions. Sort of like we're going to see this big equality of opportunity. Well, I think being in these places before was just so critical because you didn't even know what you didn't know. To some extent, you can ask the models now. if you don't know anything about VC fundraising, you can ask Claude, and a lot of these things, that there was never a website, there was never a blog that explained how any of this stuff worked. It's almost as if access to a mentor has just dropped significantly. It's maybe one way to phrase it. And so, yeah, I think you're going to get this sort of global dispersional opportunity with maybe more sort of smaller unknown groups showing up in strange places and bringing the companies from strange places and getting quite large.
Yeah. So it can be a centralizing technology, but at the higher levels of the stack, it's also a decentralizing technology because you need smaller groups of people.
I think so. But so one of the things that I often think about is, okay, we're now using, we use all the models, but if OpenAI decided, hey, Pluralis is really doing some risky stuff, let's turn off their access to our models. Big problem. Big problem.
Yeah.
And this is the kind of power these people have now.
Totally.
So it's another reason why you're like, well, we better get the stuff in the Pluralis form effective quicker rather than later, so that there's an actual backup here for people like us.
Yeah. Maybe you should slow down on getting more attention on what you're doing before it's ready.
Maybe, yeah.
So we're all using these tools today. We're using O1 Pro, R1, O3, whatever. These are all continuing to improve. And you're talking about the kind of decentralized track outpacing all of them. What are you preparing for in your own work? Like, what are these models capable of in a year's time, in 2 years' time, in 3 years' time?
That's a good question. Yeah, I don't think that pace of innovation is slowing down. So it's very clear now that like R10 is just so elegant how it's formulated, where you just need a verifiable reward and the model can continue to get better. So I think in every domain where it's straightforward to have verifiable rewards, we see very rapid improvements now. There's things like maths and code. So I think software-wise, we're going to have really, really capable agents very shortly. And you'll be able to give these long horizon tasks, as in, I would like you to go out and develop this almost at the library level, not at the file level, which I think they can do today. So I think we'll have big progress there.
Because they have the reasoning ability and they have the verifiable, correctness on the other side of it.
Exactly. If the key thing is this verifiable programmatic reward.
Yeah.
If you can tell if something is correct programmatically, there's now a clear paradigm that the model can just get better at that. But it means that for tasks where it's not clear if something is right or wrong or not, potentially you won't see as much progress. So, I know one of the things the large labs are doing is they're just trying to go out. You need to get human evaluators for all these tasks and be like, was this done correctly or was this done badly? That scales a lot slower than just did the code run? Did it run correctly? Did it pass the unit test? Was the answer correct? So I think on that side, it's TBD. But I expect large progress. I think they're going to keep getting better. May even be faster than sort of last few years.
Yeah. That's another fascinating aspect of this. It's like another cut at the it's knowledge workers rather than, physical blue collar workers that get replaced first. And of the knowledge workers, it's like the hard sciences, engineers, like those get replaced first. Or I guess everyone's getting replaced, but it's harder to replace a very adept like psychologist where there's a lot of nuance and subjectivity in how they come to their judgments.
Yeah. Psychologist, I'm not so sure, but I think like blue collar manual labor like jobs, I think they're completely safe for the short term until you have some kind of real humanoid robotics. But I think that's a bit further down the path. It's really knowledge work that is going to be affected the most, which is weird. I think it's the opposite of where everyone expected, but it's where we are.
Well, good stuff, man.
We touched on a lot of stuff. We've been all over the place.
Maybe we'll talk again in a year and we'll be in the middle of the ASI revolution. Hey, I have a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really appreciate if you leave a rating and a review for the podcast. It might seem like a small thing, but it actually makes a big difference to help other people discover the show also. Thank you, and I'll see you again soon.